Okay, we're going to do piecewise functions. So, it can be hard to understand what they're really talking about. But remember, this stands for this function notation. So f at x is the equivalent of kind of saying y. Okay, so I'm going to rewrite these twice so that it kind of makes sense. We're going to break it into two equations. Essentially what it's saying is it's one equation to the left of 1 when x is 1. So to this side of that, it's one equation. And then when x is equal to or greater than 1, so at this spot, and greater to, it's a whole nother equation. Okay? So what we're going to do is I'm going to rewrite it, and I'll put it like a parameter. So when x is greater than 1, our function, f at x, is equal to just that number 2. Okay, so that's what that's saying. So there's our first part of our equation. And then what it's saying is when x is greater than or equal than 1, we have a whole other equation. Again, f at x is equal to 3x. So the reason they write it this way is so that they only really have to write it once, and then they can list, because they can start listing 4, 5, 6 different types of equations depending on where it is. This way it kind of makes it a little clearer. We have a parameter on top and then the equation. You're probably more used to seeing the equation like this, f at x is equal to something. So in other words, if f at x, do you remember what variable or what we can say that's technically equal to when we're graphing it?
It's y.
Yeah, so in other words what it's saying is just y is 2. Okay, so if y is 2, that means we're right here. Y is 2, and if y is always 2, it's essentially a horizontal line at 2. We have to draw that horizontal line anywhere from when x is 1 and then to the left of it, because it says when x is less than that. So let's draw our line here. I got bad vision. So 2, and it's just going that way forever. Okay, so that's our first line here. And now with piecewise functions, because this one says less than 1, at 1 it's not technically that value. So what we usually do is we put a hollow circle there, saying that at that value it's not quite that equation, but anything less than that it is. And then when we're actually starting at x is equal to or greater than 1, that's our new function. So we actually have to figure out what that new function is. So in other words, to figure out where we're going to start, essentially we're going to plug x at 1 into this. So when f at x is 1, what is our function going to be? Well, 3 times 1, f at 1 is the value of 3. So in other words, when x is 1, our value is 3. So it actually starts above that. And we put a solid circle for that one to say at that exact point, that's where our equation starts. And then from there, it looks like we have a linear equation, right? This is technically to the power of 1. I know we haven't done a linear equation since for quite a while, right? Yeah. But from that spot, we would technically think this is the slope of it. So our slope would be 3 over 1. So we essentially go up 1, 2, 3, and over 1 should be our next point. To test it, we'll plug 2 into that value. So we'll find f at 2 just to make sure it's technically a linear equation with this slope. So we'll test it out. Let's find f at 2. Well, f at 2 is going to equal 3, and then we're going to replace our x value with the value of 2. So when x is 2, our y value is 6, which is exactly what we found in terms of slope. Right? We said that our slope was going to go from here, it was going to go up 1, 2, 3, and over 1. So we have a linear equation that with a slope of 3 from this point. So it kind of takes off. That's about right. Okay? So this is the piecewise function. Anything to the left of that when we graph it is just a horizontal line of 2. Anything to the right is a linear equation with a slope of 3. Let's do the entire page. Okay? So that would be 1a from that page there. Okay?